There we are. Start your introduction.
All right, I'm going to steal the microphone. Welcome everyone to the 1 p.m. speaker. I'm going to introduce Rod Nadeau of Innovation Building Group. He has been for over 3 decades preparing award-winning building services in British Columbia, focused on energy efficient design and building practices. His team has developed award-winning multifamily projects in Whistler, Pemberton, Golden, and the Sunshine Coast. I am very much looking forward to seeing the sort of innovative techniques that he's going to share with us today. I don't want to take any time away from you because we've already eaten up a bunch with the tech issues. So, Rod, take it away.
Thank you. I always like to start with this slide because it shows the unintended consequences of some of the things that you build. So these guys forgot to insulate their floor and they melted their foundation. So that's what happens when you build on permafrost. I just wanted to put that up as a graph. So all those buildings on that side, they cost more to build. And that was the net zero energy challenge that Clean BC put out. And you'll notice the 2 buildings on the other side cost less. So ours is the one on the end, and it costs 32% less than a code minimum building. And that was for a building that exceeds Nadeau standards, and the units heat for $30 to $50 a year. So yes, it can be done cheaper. But at the same time we built this, there was another building built in Whistler to the Nadeau standard. It cost 3 times per square foot that this building cost. Please flip through there. So one of the things coming up, we have the BC Energy Step Code, and we have the Carbon Code, which is set up like a step code as well. And so by 2030, all the buildings are going to be all electric and they're going to be high performance. So if you don't figure out how to do it now, you're going to be left behind at the station and it's going to be very expensive to catch up. So that's why we decided to get well ahead of the curve on figuring out how to build climate resilient, energy efficient buildings. And we kind of flipped to climate resilience as our design strategy now because we've had to add in wildfire smoke mitigation, fire smarting our buildings using non-combustible finishes, and also try to decrease the maintenance costs. We're a design, build, and we self-perform the work ourselves. So we've got carpenters and laborers who own our own machines and crane, and everybody in the company, other than a few people in the office, have all worked on job sites, and that's how they started their careers in construction. Can you flip another one there? Problem with design? We've got 10,000 choices out there, and how do you narrow it down to the choices that actually work? And that's something that we've been doing for a long time. This is a rendering of our building in Golden. We just finished that in August last year, and once again, those units they'll heat for $30 to $50 a year, and that's in the mountains in Golden. And then took that picture last summer. That's the finished building. And so if any of you are builders, we built that for $275 a square foot, and that was our total project cost. That was land, hard, soft cost, everything. Wish I could do it for that again. Prices have gone up a little bit. So just thought I'd throw that in there. It's easier to build a high-performance building than teach your 4-year-old to run the excavator or drive the company truck or teach them how to do the walk around in an airplane. So he's getting pretty good at it. He understands everything now. So this is really not that difficult to do. When we started, my first high-performance building was in 1988. We built a triple weather pane window with an HRV home. And it worked well, but it was a real pain in the ass. And ever since then, we've been trying to make it easier and more cost effective. So these are 2 buildings that we did in ICF right to the roof. Worked well. Not as well as we'd like. Then this building here, excuse me. I actually live in the top corner unit. We built that in Whistler in about 8 years ago now. And it worked very well. It was a very high performance building, but the method we chose to build it was a little too expensive and too difficult to do. So there's a picture of the building finished. And then we decided to try something completely different. We built this building in Pemberton. So that was ICF foundation. And we did a double wall to the inside to add more insulation. And we found that it worked well, but the problem with it is it just had too many issues with all the trades and sequencing of the building construction methods. So there it is finished. Turned out great. And we used these open web steel trusses and a concrete floor. We did that so we could run all our ventilation system anywhere we wanted in the floor system. Once again, worked great for the intended purpose, but the unintended consequences. That's all the things you didn't think of that cost a lot of money and took time. And this here is just a standard building. Then this one here is where we finally got it right. So we finished that building in 2020, and we went back to just standard 2x6 construction, and we used an exterior insulation on there with a stucco finish. And everything in that building from the inside is just standard 2x6 construction, and everything is off the shelf except the HVAC system. And so then we had no issues with our sub-trades. Everything was familiar to them, and they already knew how to do it. So there's the finished building, completed in 2019. We really finished it in 2020. You just flip another one. So any of you who are building, absolutely dead simple. But the big change we did here is, that's the roof trusses. And we used optimum value framing, if any of you are familiar with that. So we do everything 24 inches on the center, and every stud, floor joist, and truss in the entire building line up with each other. Doesn't matter where the wall starts. I learned to do that 40 years ago as a carpenter from someone who learned to do it 40 years before. And the big advantage that we found with this is now we can run all of our mechanical, all our plumbing, all our HVAC straight down through the walls. There's no jogs for any of the walls, any of the studs. Every trade can walk in there, drill 1.5 inches away from the stud, and know he can go all the way to the basement or all the way up to the attic. And it's 15% less building material. So you save money, and it makes every trade's job easier, which was the goal of using that and lining it up. Well, got also again, better flip past that one. We've already seen that one. That's the buildings that we framed in Golden. Absolutely the same as any other building you're seeing framed around here. There it is finished. That's our nice little patio in the back. The guys had a leftover pallet of cement, and they built all those tables one week. And there's the front. We had a bike wash and dog wash station, and a picnic table for some leftover beams. This is a building that we're going to be building in Seashell. We just finished the design work on it as a building permit, but we're going to hold off for a year because we designed it as a rental, and it economically doesn't work as a rental today with the higher construction costs and higher interest rates. So not sure when we're going to build it, but probably next year. It's another project that we're doing in Seashell. This one here is on track to start next year. These are for sale condos. And the big difference here is we put those peaked roofs on so we can put all of our mechanical systems in the roof now. And it just makes installation, layout, balancing very, very easy. There's an 8-plex we're going to build at the ski hill. Once again, high performance building. You just flip through the next couple here quickly. There's a house that we just finished, step 5. There's a duplex project we're starting May 20th. That'll be step 5, another version of it. Just another picture of an inside one of the houses. So the reason I wanted to show those pictures to you and the history is, if you keep the shape of your building relatively simple and you use design principles to optimize all the materials and systems you're going to use, you can keep your costs down in your building and build a high performance building. So they can take any shape or form that you like. There's a lot of talk about using mass timber. We've opted to use lightweight wood frame construction, so we don't use it as much timber. So while using a lot of timber in your building is better than concrete, you've got to cut down more trees to do it. So we always look to optimize every piece of material that we put into the buildings. We also have to design them for wildfire smoke. Last summer we had an awful lot of that. So the central ventilation system, we put MERV 13 filters in, which filters out wildfire smoke particulate. So you wind up with healthy air inside and just leave your windows closed if it's smoky outside. Just fire smart, some of the things that we do. In our big buildings, we put 1 meter in. Because we have central hot water, central heating, cooling, ventilation, there's not a whole lot left that you can meter for a unit's use. And we found it just doesn't matter. In one of our buildings, we had a tenant who wanted to keep their unit at 26 all winter long in a really cold winter. And at the end of the winter, we found that she'd used an extra $10 in heat. And we realized it just doesn't matter. The cost of actually administering individual meters is way more than the individual cost that anyone could spend on hydro. So we stopped doing it, and everybody saves money doing it that way. Just motion sensor lights, another little thing that we do. Soundproofing, super important in the multifamily buildings. So we pay a lot of attention to that. That's the biggest source of complaints, so we make sure that we do that well. We also are putting in rainwater collection now that we use for the irrigation. It's fairly inexpensive, and if you're on water restrictions and you can't irrigate, it really helps to have 10,000 liters of water in a little tank somewhere to use. Just flip through the next one there. So this is something that we do. That's the garage in our apartment building. So we have individual garages. So you can rent a garage where you can park your car outside. But if you've got, a kayak, 6 bikes, a road bike, 8 pairs of skis, an ATV, you're going to rent a garage to keep all that stuff because there's no place in an apartment. And we found that was one of the best things we could do to make our apartments livable. And also, as an apartment building owner, we rent them instead of them just being for free. So we make a little bit more money on it, and it helps pay for the cost of the actual cost of parking. Throw a workbench in every one of our buildings. So if you live in an apartment, there's no place to tune your bike, fix your skis, do a little project. So all the stuff I'm talking about is design related to making all our buildings livable. Community garden. A long time ago, we used to put hot tubs into our condo buildings. Hardly anyone ever used them. It cost a fortune to maintain. So now we flip to community gardens. We don't do any maintenance. The tenants do it all for us. We just provide gardening tools, and it is the most used and most requested feature in our buildings. This little series of pictures here is how an engineer can spend $50,000 of your money just like that. Our engineer designed a rainwater collection system with all these super cool little plastic boxes, he rated to drive over and everything. And I priced it out and I hit about $40,000 to $50,000. And I called him and said, what was wrong with what I asked you to do? Which was like a drain rock pit, with the distribution system. And he said, well, there's no problem, it just takes more area. So we've got acres. It doesn't matter. And so then we built it, dug a hole, filled it with drain rock, pulled distribution in, did it in 2 days, it cost under $4,000. So the biggest thing that we do is we pay very close attention to everything on the drawings, everything the consultant wants us to do, no matter which engineer it is. If they're putting stupid stuff on the drawings, we have them take it off because one sentence on a drawing can cost you $50,000 or $100,000. And we stopped having the architect coordinate all our consultants because they're not good at it either. So we have our project managers and myself do it. And so we make sure every single piece in our building fits, it has its own spot and space, it doesn't conflict with anything else, and it's something we actually know how to do and works. So We just use plastic for our footings. Gives us a little break on the bottom so we don't get water wicking up. And it also means all of our 2x6s that we take off the footings come out clean, we can reuse them. And we don't have to use 2x8s, 2x10s, or 12s. We just use 2x6s that we reuse. We use ICF for all our foundations. We've been doing that for 30 years. We've gotten good at it. It's Lego for adults. It's a lot of fun. And it's 3 times faster. We use compatible products with it to make sure the building inspector doesn't show up and go, well, that doesn't go with that. And then you got to spend a month trying to figure out how to convince the building inspector the 2 products work. So we make sure it's about, that's our parkade that we're framing right there, a couple of steel beams to carry the loads. But we don't do a concrete parkade. So we save $1 million on every building at least by not doing a big podium-style concrete parkade. We just figure out all our bearing from the roof down through the walls into the foundation, and that gets us the garages, saves us a ton of money, and we get a great feature in the building. And also, we don't have the concrete guys up where we're generally building. We know how to do the podium-style slabs. Once again, just a nice picture of, see how everything lines up? You know, any trade loves that. You can run everything in straight lines. And I just flip through these quickly here, just more pictures of the framing. Like that one there, you can, well, this is our timber frame. We like doing timber framing when we can. We just flip through all the timber frame pictures. So we've got some guys who are very, very good at this. And so that's how we create some big, wide open commercial spaces where we have commercial on the ground floor. So we just do it out of timber. There's some nail laminated panels. We just make them on site. And there's the A-team building the building in Pemberton. We pre-frame all our walls, but we do it on site. So we have our own framing tables and cranes and everything. And rather than get it done off site, where we have the room, and we have enough carpenters, we just do it on site ourselves. And that's typical Canadian construction weather. You flip through those, and you have to design everything to be able to work in that weather, in that weather. Well, there's a nice day. That was a fun day. This picture here, you see that nice little bulkhead going across the wall there? So most of the buildings you'll see, in every unit you'll see 4 or 5 vents coming out of every unit. Well, they cost a lot of money, so we designed a central ventilation system in our buildings so we don't have all those bulkheads. In like, 40,000 square foot building, it can cost $200,000 to $300,000 to put in. And nobody ever said, oh, look at my beautiful bulkhead, the kitchen cabinets. So we just designed them out and saved the money. So that's the part of the system. So that's an 18-ton Mitsubishi heat pump hooked up to Swagon ERV. And so that will heat and cool, do the ventilation, and do the hallway pressurization for a 40,000 square foot building. And that's about the size you put in a 5,000 square foot home. So when you build a high performance building, that's one of the areas you save a lot of money on, is you can downsize a lot of your equipment. That was the duct layout that we planned in one building. It's pretty complicated, but we designed out all the conflicts, and we just go to the next one. And then we just flip through these. There's the big bulkhead we did in the top floor. And then there's the bulkhead we framed up on the roof to make room for the ventilation equipment. Some more duct pictures. And there's getting a little more complicated with all the balancing dampers and elbows coming out. And then we did another building, and we simplified it a little bit more to make it a little more straightforward. So that's our mechanical room, and that is super simple to balance. It's all in one spot. So any in the HVAC trade, that's a dream when you're trying to balance that stuff. And you just flip through the next few quickly. There's just these supplies for each unit. We have our carpenters drill the holes, and not the sheet metal guy taking out the plates with his chainsaw. And then we insulate everything. And this is really important on a bigger building. And actually, we go around and spray paint every stud cavity for every trade. So you've got your spot for your stuff. You can put your HVAC equipment here, you can put your plumbing stack here. And if you don't do that, somebody puts something in the wrong spot and then you can't work around it. You just flip through these, another couple pictures up there. Now he's sticking it all in mechanical. This is a much simpler version of those last two pictures. And then we design it all now in a 3D CAD BIM model, which makes it easy to take all the conflicts out. And you can see we have a couple little mini splits. They're doing the commercial level on this building. So we're using those in houses. That whole system you saw there is controlled by that one little controller. So we've got the heat pump, the ventilation, corridor pressurization, everything in this one controller, and it's online now. Well, in our parkade, you have to do a big ventilation system, so we just do an inexpensive HRD and stick it in there, turn it on, run it 24/7, and then the parkade never smells like an underground parking garage. So here's the, on our bigger buildings that we do with stucco, the pink, so it's just a standard frame building, and the stucco guys show up, they trowel on that liquid air water barrier, and that makes our building airtight and watertight. Then they put on the styrofoam for the ethos, and it's got a rain screen built in. And just flip through the next few quickly, and you can see the guys working on it. And then, oh, this is that's your picture. That's our window prep right there. So we use that liquid air water barrier. You can see the fiberglass reinforcing to a little slope on the sill. Just take a piece of leftover plywood, cut a little bevel on it, and nail it in. Super soap. That's pretty easy to do. You know, you put the fiberglass tape there, you get your little 4-inch roller, you roll it out, and you're done. And then flip through the next one there. Then we just put that sill on, and that's a piece of Siga tape. Now we're ready to put the window in. And there's our vector windows that we use. And there's an installation where we've just put it in. Nice thing with the flangeless windows, we get to put them in from the inside. So we don't have guys 3, 4, 5 stories up on scaffolding trying to put 300-pound windows in. So it makes it a lot easier. And then all we do to make it airtight and watertight, we just put 3 pieces of tape around the 2 sides and top, and we're done. That's our window prep, which is way easier than using the old tar paper, where you drive by the buildings, they got the little bit of Tyvek all flapping in the wind. It stays there for 3 months before somebody finishes. Well, it's not much good after 3 months. So, and then that's the finished look. And because we're doing the stucco, we lap it over top of the window frame, and we don't have an uninsulated gap where the window, there's a 1/2-inch gap between the window and the framing. And then we just have this black caulking that we spray and caulk around the penetrations, and that makes our building airtight. There's our deck framing. So we just cantilever out some glue lambs and some Sherpa clips, clip in some glue lambs, and we put aluminum decking on top of that. And that gives us a durable, no maintenance, and the aluminum is cool actually with the coating on it, and makes it waterproof. And there's just a little detail of the finished look. There's the finished deck. There's just a nice little post detail. It's a little Simpson post holder. That keeps the post off the concrete and keeps the bottom of the post dry. I can't tell you how many posts I've had to chop a foot off the bottom that were rotten and pour the pedestal up another foot to repair, water damage. It's just sat there. We had to design our own heat pump hot water system for our first building because we couldn't actually buy one. So that was the first diagram of it. And there was our first installation. And those standards are so quiet, this is my buddy trying to see if it's running. So they're about the quietest heat pump we've ever used. We put one in the mechanical room because the mechanical room is really hot and that cools the mechanical room down. So we kind of double savings out of that. Now that we've figured these out, we're using fewer of them, and we've got the system working a lot better. We have, because there's water in them, there's a 1 foot of water line out to them and back. So we heat trace that. And in the event of a power failure, which only happens -30 and blowing in the middle of the winter, We just plugged the heat trace into one of those little UPS systems. We just bought it off Amazon. Our electricians designed the system. It's going to cost about $12,000. And that's an $1,800 box you buy on Amazon. It shows up 3 days later. So simple, simple, simple. And there you can see where we've heat traced them. And they have a little controller now when we have multiple systems, which helps control them. And then in a big building, the water recirculation lines generally use way more energy than you're consuming in hot water. And so by super insulating our water lines with the spray foam, we've reduced that down to almost nothing. Because the water doesn't cool down, we don't have to run the recirculation system very often. In our next building, we're actually going to tidy that up a little bit, put them closer to some walls to make it easier. That's just, we go through the technical stuff. That's our backup electric boiler for the hot water system. And they're the guys doing the air test. And we hit a 0.2. So Pascal standard is 0.6 air changes per hour in a 50 Pascal depressurization. And in commercial buildings, we tested to a higher rate, to 65 Pascals, and we hit a 0.2 air change. And that was a crew that had only done it once before. They'd never done it before, it was their first time. So you've got to keep all the air tightness details really simple, because if they're complicated and they require workmanship, you set people up to fail. So we actually had nobody really paying attention other than the site super and a few of the carpenters to our air tightness details. But because they're all done on the outside of the building with the sheathing, they don't get damaged and they're easy to do. And not having 200 or 300 penetrations in the building, it makes it a lot easier as well. So there's the A-team in golden. That's our controller. Took that one day in Pemberton. It was 41.6 degrees. That was the incoming air. We're delivering it at 13.7. And in that heat wave of 2021, we kept that building cool. It's the only cool building in Pemberton. That's just a picture of our coffee shop. So in houses, we found that the insulation doesn't work quite as well, but it works quite well in housing. So this is just how we build a double wall to the inside. And we find, a couple of carpenters in normal house taking about 2 days to do the few interior walls you have to do. But what it does, we build the 2x6 walls, we insulate them. We use these new smart vapor barriers. That one's from Intello. You can get them from Rothblast and a few other companies now. So it's really easy to insulate because there's nothing in your walls. And then we have the interior wall for cavity wall for plumbing and wiring and anything else in there. And then we just drywall it. So there's just how we do a penetration and tape it up. And then there's a whole variety of HRVs on the market now. The Zenders were all Pasadena guys wanted to use, but they're $5,000–6,000. So we switched to these Venmars now. They're about the same efficiency level, but they're $2,000 instead of $5,000 or $6,000. We're using heat pumps now. That happens to be a Senville. It's made by Midea. They make half the heat pumps in the world, so there's a ton of brands of heat pumps out there. They're all made by one company. There's one we're getting from Nova. That's a combination ERV and heat pump. We've got 3 of those running in a couple houses now, and so far they're working pretty good. But it's new technology, we have to get used to working with them. Once again, it's just another picture of our building we're about to start. And that's our most efficient building, I think, in terms of unit size, energy efficiency, hiding all the mechanical equipment. And you just flip through these, and these are just some of the pictures of the units. So there's no difference in any other condo you would see around here. Okay, we know where that is. That's Joffrey Peak up north of Pemberton. There was a slide that came down a few years ago. It's pretty wild. Filled up the whole valley below it. And that's my grandson and I walking up the ice walls on Whistler Mountain in June when they plow the road out. And that's the Catskill Glacier in the Yukon coming out of the St. Elias Range. And my next door neighbor has the exact same picture taken in 1967. They look identical, except the end of the glaciers melted back so far that it used to flow to the Bering Sea, now it goes to the Gulf of Alaska. So the drainage has completely changed. And those are all the slides. Got through them pretty quick.
We've got 20 minutes or so for questions.
So we do renovations, single-family homes, duplexes, buildings, commercial stuff. So I can answer questions on just about anything you'd like.
What are your square footage costs, like sort of an average? Is it higher or cheaper than sort of most of the bigger construction?
Well, the cost study done in our buildings, showed them to be cheaper than a standard code minimum building. So the building in Pemberton, our hard costs in 2020 was 148 a square foot.
What?
148. That was hard cost. That wasn't site prep. That total project cost in that one was 225 a square foot. That was land, soft, hard, everything. And our houses were ranging from about, right now, about 250, and we just finished one at around 800 a square foot. They can get expensive fast.
Why aren't more builders doing what you're doing if it's that cost efficient? And I mean, like your picture showed the beautiful buildings. So why are not other builders doing that? I was just involved in a project at Port Moody, redesigning our church and putting apartments and everything in. And we probably could have saved hundreds of thousands of dollars in that building because we did a cement underground parkade and, the usual stuff, right? So why isn't this more common?
I'm just as lazy as all the consultants we hire.
Okay.
And so we're just redoing our buildings and we make little improvements here and there. Well, all the engineers, consultants, and architects are doing kind of the same thing. But they didn't start the innovation curve 40 years ago. They're getting on the train now.
Okay.
So there's a huge lack of knowledge, and it's mostly in design and engineering, and a lot of the builders who are doing this stuff. The building industry is very slow to change. And that's probably the biggest reason people aren't doing it. And the other reason is, I just came back from the National Housing Conference in Ottawa, and I was giving a talk similar to this. And the next day I had a meeting with half a dozen engineers from Enercan. And they're trying to design these programs for energy efficiency. They have no data on any of these costing less, because mostly they cost a lot more. And if you ask the energy consultant in the room here, well, if you want triple pane windows, they cost this much more. If you want to make it airtight, it's going to cost this much more. You want to use a heat pump, it's going to cost this much more. You want to do an insulated concrete foundation, it's going to cost this much more. So that's all true. But if you look at ways to save in some of those areas, you can get those costs back down. But it's the areas that we don't do. We don't do gas in our buildings. No gas fitters, no gas design, no gas utility bills. So we just, one gone. We took out 250 penetrations in the building for all the vents that would normally be in there. So that's gone. We don't do that. We went to optimum value framing. That saves us 15% of materials. And it saves us a little bit on labor because there's fewer things to handle. We use an EFIS system on the outside. So the EFIS system is about the same cost as any other cladding that you're going to get on your building. So that's not a cost. We designed out all the thermal bridging. You go to BCIT and look at all their wall models and everything. They always wild clips and all kinds of ways of dealing with it, of adding on the insulation. They all cost a lot more. The EFIS, they just call up the 8X guys. They show up with 10 guys. They do our entire building. They make it airtight, watertight, and they're a little bitter. And we get an extra 6 inches of insulation. Our airtightness, as a builder, I was terrified of airtightness, trying to do the air test and where did we miss something? The way we're doing it now, we don't really have to pay that much attention to it, and we're doing a good job on it. So it's all the things you have to, as you improve the building, you have to get to a certain point, and In the step code, that's well beyond step 3, where you can start saving money.
I just wanted to ask you, the Canadian buildings, like you mentioned, the building material, I'm more into modular concrete. China and India are using that system. Canada did use that system back in the 70s. If you look at Montreal, the architect Safi, who built basically the Vancouver Public Library, the architect there had Habitat in Montreal.
I have friends who live in Habitat.
Pardon me?
I have friends who live in Habitat. Very cool building, didn't work that well practically. Concrete tilt-up construction.
But
If I was,
this is low CO2.
yeah, that is hard to get. It's coming, but I can't just get low CO2 concrete from my local concrete supplier yet.
Well, there's only 2 major companies. Heidelberg and the Dutch company.
Well, there's Lafarge and
There
then
isn't much
there's
competition
and Lehigh.
in doing concrete. You know,
Well, one of the reasons we stuck to lightweight wood frame construction is all the trades that we're working with, they're already good at it. So rather than try to re-educate the whole construction industry to new methods, our goal was to just look at the trades we have, the skill sets they had, and try to optimize those. And in terms of resource efficiency, there's probably not any method of building better than lightweight wood frame construction, especially when we go to optimum value framing, to use the least amount of resources to produce a high quality building.
but don't you have more value with concrete?
No.
Buildings, brick, silicone?
No. Lightweight wood frame construction is the least expensive way to build in Canada right now. And also, if you're looking for thermal bridging, concrete is not an insulation product. So if you're using concrete, you have a lot of detailing to do to insulate it very well and not have thermal bridging in your building.
But seismic grading on different buildings or high.
If you keep them under 5 stories, they meet the upcoming seismic codes coming in. So seismic's not that hard to do in wood frame as long as it's not too big and too tall. Yes.
Do you have a booklet on what this is? Quite interesting stuff.
There's been a few case studies done by an organization called ZEBEX, and BC Hydro did a few on some of our projects. Those are publicly available. So if you Google ZEBEX, you'll find a lot of information on high performance buildings. We're also just launching an initiative where we're going to open source the drawings for our buildings. And so we're going to be selling them at about 20 cents on the dollar to what any developer or housing provider could by going the traditional route and hiring the architect and all the consultants. And the good thing about our buildings is we've made mistakes. We've paid the price of innovation, and we solve the unintended consequences. And also because we're the builder, the developer, general contractor, and self-perform, if a mistake is made and something's not working right, there's no finger pointing. We just go and fix it and make sure we don't do it again.
Are you an architect by training?
No, I have an accounting and business degree from ancient history. And then when I moved to Whistler, there were no jobs for anybody with a degree, so I became a carpenter the next day.
Is your, well, you have basically an entire team involved with design and engineering, architect, like, are they all part of your team, or do you have just a team of people that you use on a regular basis, or to what extent, I guess, is your team?
We have 6 people in our office in total. 3 in accounting and 3 that are project management, design, and building. And then the rest, everybody else is on site. I've used the same architect for our Part 3 buildings for the last 25 years, and we do all the coordination ourselves. My son is one of the people in the office. He does the drafting, and so we do the mechanical, the structural, and the architectural drafting on one set of plans. And that's to design out all the conflicts. And then we've also got our own suite of details. So I get tired of getting details from architects and engineers and building envelope guys, and they were just really too hard to do. So we simplified them down to make them all easy.
Yeah, I'm just wondering how to, like, because as an interview advisor, a huge part of what I do, especially locally, recently, is education. And, you know, your model works really well for, you know, the individual projects that you do. How my involvement with builders is to try to educate them. Because, you know, for example, City of Chilliwack has only come online with the step codes since May, so trying to get builders and developers involved in all of this and understanding all the processes on a broader scale, it's a challenge.
The biggest problem is by the time you get involved, all the details are pretty much done.
Yeah.
The building's designed, and very few of the engineers have really thought through the effect their equipment's going to have on everybody else. And that's where we excel, is at coordination of that and simplifying the details. But if you don't do it at the preliminary design stage, it just makes your job a lot harder. And step 3, I think, is the hardest step in the step code to achieve, because all you're doing is spending more money everywhere you look. And most builders really don't like doing that, especially today with all the pricing going on. So that's why we just skipped over step 2, 3, 4, 5, and went right to net zero ready. And the advantage that we had is 7 years ago we got a MyTax grant, and we used that with BCIT. They have a building science engineering department, and we modeled every inch of our building and every single detail to figure out where to spend our money. And we found 3 or 4 things after modeling thousands of details. Thermal bridging was huge. We just designed it out, as opposed to doing all these solutions with add-on stuff. We just designed the thermal bridging out of our buildings using the EFIS. Then we found that increasing the efficiency of the HRV in that building you saw over 25 years would save us $130,000 in operating costs at today's energy pricing. And that's just by buying a more efficient HRV. So we just did that. And then windows, fortunately for a gentleman from Intertech, we're buying them from Europe because we can get them cheaper than a builder grade window delivered to our job site. So there's only 4 or 5 things that we've had to do to improve the building. And I've seen an awful lot of people try to still use poly as an air barrier. I mean, that's just a lost cause. Every single trade on the job site is going to mess it up on you. Whereas that window prep that you saw there with that gray liquid applied air water barrier, you can walk up to that with a hammer and wail on it, and you're not going to crack it. So it's pretty hard to damage the air barrier. And it's really easy to have an air barrier on the outside sheathing. So now you're putting your air barrier on something solid, something we've already got, and you're using a trade that you're really good at, because that's all they do. So there's a lot of winners and losers in innovation and change. When the carbon step codes start kicking in, you're not going to be able to use gas. You're going to have to drop all your gas, first your gas hot water heater, then you're going to have to drop your gas furnace when you get up to step 3. But here in Chilliwack, the climate's not that cold. Heat pumps work great. And then our HVAC system, we're using the HVAC system for the ventilation. And we realized once we got our building envelope down to the point where we're only 10% of the energy required to heat or cool our buildings at the standard code minimum. Well, not standard code minimum, step 3, but backward to step 1. So we're doing heating, cooling, ventilation, and corridor pressurization with one system. And we've designed all the ducts to not require fire dampers anywhere. We run it all through the attic and all down through the walls with 5-inch ducts. So it was just a matter of designing with the systems you're going to use in mind and optimizing it. So as an energy advisor, it's really, you're in a tough spot because you're getting these buildings and they didn't think of all this stuff up front.
Yeah, we've kind of noticed that we're trying really hard to work with local planners and changing their processes and having us come in sooner than later for that exact reason. It's a challenge with it being still so new that people have to go through it a few times and find the struggles in themselves before they see the
See, we've made the mistakes.
Yeah.
And we fixed it. We don't have poly in our buildings anymore. We have a wall system, there's no poly in it at all in the commercial buildings. And then the residential ones in the townhouses, it's super simple to do the smart vapor barrier and then just do a little cavity wall on the inside. And that also is very hard to screw up. And it's almost all in sequence of the regular construction process. That's another big part. We don't want to get a bunch of stuff out of sequence, or that just costs money and the trades will screw it up. There you go.
Rod, thank you so
I
much.
saw the clock.
Thank you so much for coming and sharing your wisdom with us today. I am going to present you with one of our food serving boards, cutting boards. I'm not exactly sure.
Charcuterie.
Charcuterie, perfect. That'll work for us. We really appreciate everything you've shared today, and hopefully you'll stick around if people have a few more questions before the next speaker gets started.
Yeah, I'll definitely stick around, and if anybody has any more detailed questions, I'm just going to go downstairs and hang out down there for